Okay, so today's lesson is called area between two curves, or also known as functions. Alright, so let's start with pretending that there's a function called f of x and g of x, like this. Alright, now we have f of x and g of x. Our goal is to figure out area between two curves from A to B, which makes it this purple area. To find this area, which is the purple region, let's review an area under the curve of f of x and g of x separately first. So let's review what area under the curve was. It was also known as definite integral, which was given the integral of a to b, point A to B, of a function called f of x. We said that this will give a result, something called area under the curve, referring back to that. Now we have f of x. Let's take a look at the g of x. We have a definite integral from a to b of this function called g of x is equal to that area under that line. Now we know what this area is equal to. We know that this area is equal to the integral from a to b of f of x. Now we know what this is, which is integral of a to b of g of x. If you overlap these two functions, pretend that they're going overlapping, we're taking this whole, subtracting by the small letter area, we'll get the result of this. So we could summarize this as integral of a to b of f of x dx minus integral of a to b of g of x of dx. And by property of integral, we could put them all under one single integral from a to b f of x minus g of x of dx. Now let's look a little bit more closely to this equation. F of x is your top function. G of x is your bottom function. So given any type of function, to find area between two curves, it will be area, a definite integral from a to b of your whatever your top function is minus your bottom function. Will allow you to calculate area between two curves. Now let's look at our first example. Find the area bounded by the given expression. Y equals to x squared plus 1, y equal to x. Okay, now we said the area between two curves is equal to integral from a to b top function minus the bottom function. In order to figure out what top and bottom function is, let's look at the sketch of these four graphs. So here's your x-axis and y-axis. This graph is a parabola with one unit up. So roughly, let's say here's one. The graph is going to go like this. Now y equal to x is a straight line with a slope of 1, so roughly it looks like this. Now x equal to negative 1 is roughly around here, let's say. Now let's say x equal to positive 2 is roughly around here. Our area that we want to find is this green region. So if this is the region that we want to calculate, x squared plus 1 will become top function, x equal to y, or y equal to x, will become your bottom function. So the area will equal to, from -1 to positive 2, our top function being x squared plus 1 minus our bottom function being y equal to x. Now let's simplify that integral. This will make x squared minus x plus 1 dx. Integration of x squared minus x plus 1 is x to the third over 3 minus x squared over 2 plus x from 2 to -1. Substituting positive 2 into wherever x is to calculate definite integral. And subtracting 2 is the substitution of -1. And if you calculate these values, you will get an answer of 9 over 2. And the area between these two curves from -1 to 2 will equal to 9 over 2. Okay, now let's look at our second example. It says find the area bounded by the given expression, y equal to 5 minus x squared, and y equal to 1/2 of x. And again, here's your graph. Our goal is to figure out this purple area. So the first thing is we want to figure out what top function and bottom function is. Looking at the graph, it seems like a parabola is a top function. So it will be area is equal to, from A to B, top function being 5 minus x squared minus 1/2 of x. Okay, now we have to figure out where the area starts and where the area ends. Area starts wherever these two functions meet, right around here and right around here. And when two functions meet, we call that an intersection point. And where the point intersect will be we use system of equation to solve it. So to find the point of intersect, we have to set the two equations equal to each other using system of equation, and you will find that x squared plus 1/2 of x minus 5 will equal to 0. X will equal to -5 over 2, and x equal to positive 2 as the answer. Which means our integral is from -5 over 2 to positive 2 of -x squared minus 1/2 of x plus 5. if you integrate this, you're going to get negative x to the third over 3 minus x squared over 4 plus 5x, and calculate this from negative 5 over 2 to the positive 2. So it'll be negative 2 to the third over 3 minus 2 to the second over 4 plus 5 times 2. All of this will get subtracted by negative 5 over 2 to the third power over 3 minus negative 5 over 2 to the second power over 4 by times that value. And if you calculate these values, you're going to get 243 over 16 as your area between two curves.